DeepSeek just released an AI that simulates physics so accurately it's making physicists genuinely uncomfortable. And I'm not exaggerating. This isn't a chatbot that sounds smart. This is a system that can predict how objects move, collide, deform, and interact with forces in ways that used to require supercomputers and PhDs. Let me back up. Most AI ChatGPT, Claude, whatever, they're trained on text. They predict the next word based on patterns they learned. It's statistical guessing, really good at it, but it's still just pattern matching on language. Physics simulation AI is completely different. It's learning to understand the actual rules of how the physical world works. And that's terrifying for a specific reason I'll get to in a second. First, what is DeepSeek's engine? It's a model trained on physics data, simulations, real-world measurements, videos of objects moving, and it learned to predict what happens next. You show it a video of a ball rolling down a ramp, it can predict where it lands. You show it a liquid pouring, it can simulate the splash. You show it objects colliding in slow motion, it can extrapolate the forces involved and predict the outcome before it happens. That's genuinely wild. But here's the thing that's actually scary. This isn't just useful for animation studios or video game designers, though it is for those things. This is useful for things that don't exist yet. Weapons, drones, systems designed to move through and interact with physical spaces in ways we haven't seen before. And an AI that understands physics better than most humans means it can optimize designs for outcomes in ways we might not have thought of. Let me be concrete. Right now, if a defense contractor or a robotics company wants to design something, a weapon system, an autonomous vehicle, a robot that can navigate terrain, they have to simulate it. They hire physicists, run expensive software, iterate. It takes months. DeepSeek's engine can do that in seconds. Not approximately, accurately. It's learned the underlying rules well enough to predict real-world outcomes without running a traditional simulation. Why does that matter? Because it compresses the design cycle. It means someone with fewer resources, less expertise, and less oversight can design and optimize physical systems faster. And because it's AI, it can explore design spaces humans wouldn't think to explore. It can find solutions that are physically optimal but weren't on anyone's radar. Now, I want to be careful here. I'm not saying DeepSeek is secretly weaponizing this. DeepSeek is a Chinese AI company, and they've been transparent about what they're building. But this technology, physics simulation AI, is now public. Anyone can use it. And it's spreading fast because it's genuinely useful for legitimate things: materials science, climate modeling, drug discovery, robotics, manufacturing. The problem is that the same capability that makes it useful for those things makes it useful for designing things we probably don't want designed. Here's the deeper issue. We've gotten used to AI being limited in specific ways. ChatGPT can't see. It can't execute code on the real world. It can't move anything. It's constrained. But an AI that understands physics? That's a tool that directly interfaces with how the physical world works. It's like the difference between an AI that can tell you how to pick a lock and an AI that can design the lock-picking tool for you, optimized for every lock type. One is information. The other is a capability multiplier. And here's what keeps researchers up at night. We don't have good governance for this yet. There's no international agreement on physics simulation AI. There's no export control. There's no way to prevent someone from taking this model, fine-tuning it on specific design problems, and using it to design things faster and better than anyone else. The model itself isn't classified. It's not restricted. It's just out there. The second scary part is more subtle. These models are being trained on real-world data, which means they're learning from physics as it actually occurs. But physics is deterministic. If you know all the inputs, you can predict the output. So as these models get better, they're essentially learning a compressed version of the laws of physics. And the more accurate they get, the more they become a direct interface to predicting what happens in the real world. That's powerful for prediction. It's also powerful for planning attacks, optimizing weapons, designing systems to cause harm. I'm not being paranoid here. This is what security researchers are actually worried about. There was a paper last year about how AI models trained on physics data could be used to design bioweapons more efficiently. The same principle applies to any physical system. If an AI understands how things move and interact, it can optimize designs for outcomes. And unlike traditional engineering, It doesn't need a human to understand why the design works. It just works. So what's the solution? Honestly, I don't think there is one yet. You can't uninvent this. You can't ban physics simulation AI without crippling legitimate research in materials science, climate modeling, robotics, medicine. But you can regulate access, you can monitor how it's being used, you can invest in detection systems that catch when these models are being misused. The real issue is speed. AI is compressing timelines. It used to take a team of engineers months to design something. Now it takes seconds. And we don't have policy or governance that moves at that speed. We're trying to manage 21st century technology with 20th century regulations. And that gap is only getting wider. Here's what I think matters. Understanding that this is happening. Not all AI is a chatbot. Not all AI is limited to language. Some of it is learning to directly interface with how the world works. And that's both incredibly useful and genuinely risky. The companies building it aren't evil. The researchers aren't trying to break the world. But the capability is there, and capability spreads. So if you want to actually understand what's coming, not the hype, not the panic, but the real implications of AI systems that understand physics, materials, systems, dynamics, subscribe. I break down one of these every few days, and honestly, staying ahead of this stuff matters more than most people realize.